All right, here we go. Exercise 9E, tree diagram. So this week, which is today's Wednesday, you got Thursday, Friday, you got this week. We're only just going to work on 9E. Next week is 9F, and I gave you just that new booklet right now. We're going to do that booklet next week in replacement of exercise 9F. Okay, so don't lose that one. Keep on to that. If you do lose it, it's in your OneNote now as well. There's a digital copy there. Okay, well, let's start off with exercise 9E, tree diagrams. Here we go. Tree diagrams, we use list to list sample space. So write that down, sample space. We use tree diagrams to list out sample space, but specifically for experiments or problems with 2 or more steps. So remember, these exercises that you're doing, they're just tools. So you learn Venn diagram, you learn two-way tables, and you're learning tree diagrams. They're just ways for you to solve a problem systematically. You don't have to use them later on, but you just have a set of tools. Yeah, sure. All right, so here we go. Example, if you want a quick copy, it's just, there's one in front of us right there. If you just want a quick one, there's a spare copy there. It's up to you. All right, example 1. I'm sorry, I'll zoom out if you didn't copy that down. Sample space, and you do them for when you have 2 or more steps. That's when we normally use a tree diagram. Here's an example. Say you got 2 regular 6-sided die. So if I got a dice and I got another dice, and I decide to roll them both at the same time, right? What happens then is it is noted if they show an odd number or it is shown that they have an even number. Okay, so you can get a 1, that's an odd number. Then you note it down, you say it's odd. If you get a 2, then you say, well, that's an even number. You note it down and say it's an even, right? So here's the question. How many possible outcomes are there when you roll a dice? So you roll once and you roll the other one. There's 2 of them. What are the possibilities you can get? So you can do it in your head, which you can, or you use a tree diagram. So here, let's use a tree diagram here to see how many possible outcomes you can get. When you roll your 2 regular 6-sided dice, so roll it out, you get 1, you get 2. What are my possible options again? So I roll my first dice, so here's my first dice. When I roll the first dice, what are my possible options? Odd or even. Yes, I can get 1, 2, 3, 4, 5, 6, but remember, I only note, is it even or is it odd? So I only got 2 options there. You either get odd or you get even. So that means you can either have the numbers 1, 3, 5, or you can have 2, 4, and 6. So when you roll the dice, that's your first dice. You get either 1, 3, 5, 2, 4, 6, odd or even. You note it down. Then you roll your second dice. So this is why it's called 2 or more steps, yeah? So you roll your second dice. So here's your second dice. If I roll my second dice now, what are my possible options here? Mohammed, what do you think? What could I get? So if I rolled the first one, I could have got an odd. If I rolled the second one, I could possibly get an even or an odd. Yeah, so you get another 2 options. So here we got, you can get an odd, you can get an even. Does that make sense? So think about it. If you roll the first dice, you might have got a 1. Then you would have said odd. Then you roll your second dice, you might have got a 4. And that's even. So you've got odd, then even. So it's 2 steps. See how that's 2 steps? But how many possibilities can you get in 2 rolls? So 1 roll for 1 dice and then 1 roll for the second. How many total possible different combinations can you get? Well, if you think about it, the possible outcomes that you can get are, you could have got an odd on the first go, odd on the second go. That's one way. Another way you could have got is odd on the first go and then even on the second one. So odd, 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 even. What's my other possible options here? Can I please have? Let's go with Zach. What other possibilities could I get?
Even, odd, and even.
Very good. I can get even, odd, and then even, even. Very good. So this here tells me this could be even, odd, and then even.
Odd, even, and even are the same. No, because one of them is odd is first and the other one is.
That's a really beautiful question. Was that Reese? Yeah, Reese. That question that you just asked is exactly why probability in year 12 gets tricky, because you're right. Is even then odd and odd then even, are they the same? So if the question depends, it depends on the question. If the word says, what's the chances of getting even on the first dice and then odd on the second, then there's only one possibility. But if they ask you, what's the chances of getting an odd and an even? Well, there's two possibilities there. You could get odd first then even, or you can get even then odd. So in year 12, they have to distinguish the difference between what the question's actually asking. Is it asking for the first one must be an even, and then the second must be an odd? Or are they just saying, what's the chances if you roll 2 dices, what's the chances of getting an odd and then getting an even? Okay, so there's no order specific. Yeah, so yes, that's a very good question. And I don't think at the year 9 mainstream questions will be there, but if you do enrichment questions, they may add that kind of concept, the difference between the two. Okay? All right, so now if I asked you how many possible outcomes are there when you roll a dice, there are 4. Very good. So this is a way of listing out your sample space. The answer is there are 4 possibilities. You can get odd, 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 even, odd, or even, even. Now, this is where we start calculating probabilities. Find the probability of rolling 2 even numbers. Now, let's have a think here. We don't know what the probability is yet. I haven't wrote down any probabilities for odd or even. What's the chances of getting an odd number? And how do you know? What was that, Reese? How do you know it's 50? Oh, I see what you're doing. So you're looking at there's only 2 out of the total of 4. Later on, this will get more complicated that you can't actually draw out your tree diagram to see. But the logic is here. When you roll a dice, there's only 1, 2, 3, 4, 5, or 6. There's 6 possibilities. What's the chance of getting an odd when you got 1, 3, and 5? There's only 3 out of 6 chance to get an odd. So hence 50%, which is half. So each one, you can see the chance of getting even is 2, 4, 6. There's only 3 numbers out of your 6 numbers. So hence, this would also be half. So that means each time you roll a dice, you got half a chance. Can you see how I'm writing it out? You got half a chance each time to get an odd or an even. Now let's answer the question. What's the chance of getting 2 even numbers? Well, on the first one, what's the chance of you getting an even number? You got 50%. And then you got another 50%. So it's 50% of the 50%. And how do you work that out? It literally is half, which is 50% for the first go, of, which means times, another half. So you can see even, even. So I'm doing half is even, half a chance of getting an even, so 50% chance of getting even. But then you got another 50% of that 50%. So you're doing half times half. So when you say 50% of 50%, what you're actually doing there is you're saying half, times half, which is a quarter. And for some of you, you know that a quarter is 25%. Don't write the percentages, leave them as fractions. Don't change the decimals as well. So when you say 50% of 50%, remember the word of is times. Okay, every time you say of, half of 10, you're actually doing times. So 50% of 50% just means half times half. That's why I got a quarter. Okay, so let's do the same thing now. Let's do the next one. Whoops. Let's do the next one. So now that you got the idea of how to do them following the tree diagram, what about if you just want one even number? So in your list here, what's the chance of getting one even number? Just one even number in your list. So you got one even there. This one has two evens. Yeah, you can see again, you've got one option there, one option. That's 2 out of your 4 options, which is 50%. But if you're unsure, you can follow the tree diagram. Let's follow it. Here we go. If you want just one even number, here's one even. Even on the first go, odd on the second. So you can have half times half. This is odd. Sorry, getting an even first and then an odd second. But what's the other option you can have? What's the other way that you can get one even? Odd then even. So you could have also followed this one. You could have got odd on the first go, even on the second. So that means you got another one. You've got half times half, and that's where you get odd first and then even. See how you got 2 different branches? They can get you one even. So together, you got 1/4 plus 1/4, which gives you, it's a half, yeah, but 2/4, which makes it a half. Okay, so that's the proper way of doing it. You could have looked at your sample space and figured it out as well. There's only 2 outcomes out of the 4 outcomes that would have gave you one even, so you could have got the same answer as half. But this is the traditional way of doing it. So you're looking at your pathways and then you count them all up. Okay, let's do another one. What about when they say at least one odd number? Yes, at least means one or more. So you can have odd, even, that's one option. Even, odd, that's one option. And this one has two evens there, so that's another option. There's 3 out of the 4. The answer in a quick way would be 3 out of 4 options. Or you could have done the long way as well. You could have done half times half, plus half times half, plus half times half. And that would have given you the same answer. Okay? How's that feel so far? This is tree diagrams. So it's about listing it. Once you get the tree diagram, then it's easier to solve. But the first step is getting your tree diagram. Let's do one more example, and that's my last one for today. Here we go. I'm going to roll down. This one's a bit trickier. I want you to have an attempt. I'm going to pause the video. And I want you to have an attempt to draw this scenario in a tree diagram. Okay, so I'm going to pause the video. Here we go. I'm going to draw it. So starting from home, you can get to A. So first step to go to A, you can do train or car. After you passed A to get to B, if you took the train, you have the option of bike or train. But if you took a car, you could have taken a bike or train. And then if you did train, bike, and then after bike, well, to get to C, there are 3 possible options that you can take now. You can take bike again, you can take a car, you can take a train. So if you think about it, the possible options are, the first one is train, bike, bike, or train, bike, car, or train, bike, train. That's 3 options just for that first branch. But if you follow on, each one has bike, car, train, bike, car, train, bike, car, train. And you can see that each one has 3. That one has 3 lines, that one has 3 lines, that one has 3. So 3 by 3 by 3 by 3, 3 times 4, gives you 12 options. Now, how did I do it quickly in my head? Well, there was only 2 options for A. Then for B, you only had another 2 options. So for every 2, there's another 2. So 2 times 2 gives you a total of 4. 1, 2, 3, 4. So 2 times 2 is 4. And then for every 4, you get another 3. So all you have to do is times them all together. So you do 2 times 2, 2 times 2. That's how I get a total of 12. That's a quick way of doing it. Okay, so when you illustrate it, it makes it much easier to see that if you just times them all together, you should get a 12 total possible ways to get there. So you can see here I can have train, train, bike, train, train, car, train, train, train. So all I'm doing is I'm just following the tree diagram. Yeah? And you follow the next one, it's car, bike, bike. So I could have got car, bike, bike, car, bike, car, car, bike, train. And then your last one is car, train, bike, car, train, car, and then car, train, train. So if you count them all together, each one is a group of 3. That's 3, 3, 3, and 3. So 3 by 4 gives you a total of 12 possible options to go from home to work. And that's a systematic way of calculating this type of problem. Got 12 total. Can I get a show of hands who drew this tree diagram correctly? Hands up. Very good. That's very good. That's what exercise 90 is. That's about you illustrating it and then calculating it. Once you got the tree diagram, answering is much easier. We can say now there are 12 possible outcomes. And now let's answer the questions. If Michael randomly chooses one of these outcomes, find the probability that he will use the train all 3 times. So you're looking for probability. Train, train, train. Now, to work out the probability, each of these branches, you need to work out the chances of choosing a train and choosing a car for each branch. You need to figure it out. So, let's think about it. When you're starting at the first step, what's the chance of you picking a train versus picking a car? What's the chances? tough because you only got two options. You got two options there to choose, and the chance of you picking a train was only 1 out of 2 options. So hence this is a half and a half. Then you go over to this one. If you took train, what's the chance of getting a bike or a train? Well, it's half again. You only got half a chance of getting a bike, and you got half a chance of getting a train. But then by the time you get to your third one, you now have bike, car, or train. And if they're all equally chosen, possibly chosen, then you've got now a third of a chance for each one. So if you label it out correctly like that, then now you can answer the question. To get train, and then train, that was 50% getting a train, 50% again of 50% to get a train, and then 33% of 50% to do train. Okay, so what you're really doing there is you're saying this. I'm looking for the first train, you got half a chance. Get a train again, you got half a chance. But then to get a train the third time, you had a third of a chance. So in total, that should be 1 times 1 times 1, which is 1. 2 times 2 is 4. 4 times 3 is 12. So 1 out of 12. But if you didn't like what I just showed you, you could have looked at your sample space. You know there are 12 options there. And how many options are there? Train. There was only 1. 1 out of 12. So that was one way of doing it. Okay, so this is only good if you can draw out the tree diagram. But later on when you get to year 11 to 12, the problems get so big you can't draw it. But you can think about it mathematically. That's why I'm teaching you how to do it this way. Okay, so this way it doesn't matter how many branches you get. This one helps you if you can see it all in total. So clearly, train was only 1 out of 12. It's quicker for now, but for later, you probably want to learn it this way. Okay? All right, let's answer the other questions then. Here we go. What's the chance of you picking train exactly twice? So look in the list here. How many options has 2 T's maximum? How many options can you see? I can see 1. I can see 1 here, 2, 3, 4, and I only see 4. So it must be 4 chances of getting T, and then not T. So notice how I'm using the symbols here. I'm using T, and then not T. So T dash, T complement if you've forgotten the symbol for it. But T dash means not T, so not getting a train. The chances were clearly 4 out of 12 options, which gives you've got a third of a chance of that happening. I'm going to pause the video, give you a second. I want you now to see, you can do it through the branches way, or you can do it through the list way. List way is faster. This way is more methodical. Okay? Have a go with the next 3. I'll give you the answers in a moment, but that's it for today's lesson. Okay, so I'm going to pause the video for now. And then I'm going to pause the video. Where's the pause button?